Hi, so this question is based on volume and it involves fractions and percentage. It says tank A and B were filled with water. The height of water in tank B is 4 times the height of water in tank A. It is important to note that they are talking about the heights of water in both tanks and not the heights of the tanks A and B. Okay, so let's say the height of water in tank A is P. Then the height of water in tank B would be 4P. Next, 2/5 of water in tank B was transferred to tank A. The height of water in tank A became 20 cm. So question A is, find the height of water in tank B at first, which is the value of 4P. So before we proceed to answer our questions, let's take a look at these two important equations that are associated with volume. So V is for volume. Volume is equal to the base area into height. And 1 liter is equal to 1000 cubic centimeters. Okay, so moving on to our question, we need to find the value of 4P, or the height of the water in tank B. So if we take a look at our first equation, the volume equation, the base area of tank B can be easily calculated because the breadth and the length has been given to us. The only clue that has been given to us regarding the height of water in tanks is the height of water in tank A, which became 20 cm after the transfer of water from tank B to tank A. So since there was a transfer of water from tank B to A, we need to find the volume of tanks A and B in terms of P. Okay, so let us find the volume of water in tank A at first, where the base area is 40 into 60 and the height is P. The volume of water in tank A is 2400 P. So moving on to tank B, the base area is 30 into 50 and the height in this instance is 4P, which is 6000 P. So next we are told that 2/5 of water in tank B, which is 2/5 of 6000 P, was transferred to tank A. So 2/5 of the volume is 2400 P. So this 2400 was transferred to tank A. So let's add this up, and the volume of water after the transfer in tank A is 4800 P. Okay, so we know the volume of water in tank A after the transfer, which is 4800 P, and the base area, which is 40 into 60 cm, and the height, which has been given to us. It says that the water in tank A became 20 cm. Now we can solve this equation to find out the value of P. The height of water in tank A, or P, is equal to 10 centimeters. So if the height of water in tank A is 10 centimeters, the height of water in tank B, which is 4P, is equal to 10 into 4, which is 40 centimeters. Okay, so question B is, if the height of water left in tank B is 40% of its height, What is the total capacity of tank B in liters? So to find the height of water in tank B after the transfer, we need to find the volume of water that is left. So the volume of water left in tank B is 6000 P minus 2400 P, which is 3600 P. The value of P is equal to 10 centimeters. Therefore, 3600 P would be 3600 into 10, which is 36,000 cubic centimeters. Okay, so once again, let's take a look at our volume equation here. So we calculated the volume of water that is left in tank B after the transfer, and the base area is 30 centimeters into 50 centimeters. So now we are able to calculate the height of the water left in tank B after the transfer. Which gives us a height of 24 centimeters. So we are told that this height, which is 24 centimeters, is 40% of the height of tank B. So we need to find the total height of tank B to find the total capacity. Okay, so 40% of the height is 24 centimeters. So we need to find 100% of the height or the total height of tank B. So we divide 24 by 40 to find 1% of the height, and then multiply it by 100 to find the total height, which gives us 60 centimeters. So the total volume of tank B is equal to 30 into 50 into 60, which is 90,000 cubic centimeters. We need to find the total capacity of tank B in liters. So if 1000 cubic centimeters is equal to 1 liter, then 90,000 cubic centimeters is equal to 90,000 divided by 1000, which is 90 liters. So the answer to question B is 90 liters.